Unique ones, it's Prof G, and in this lesson we'll learn to conform to the identifiable protocol. This will let us communicate that every enum element is unique, and it'll also let us drop the ID parameter from our ForEach statement. Along the way we'll learn to create calculated properties, and we'll complete a brief challenge to confirm knowledge. Let's ID the big learning. So our Dungeon Dice app works well, but let's add some improvements. And the first thing I want to point out is that when we created our ForEach statement in the earlier lesson, we needed to include this ID parameter. Now we mentioned that we needed to do this because the ForEach statement needs to be able to tell apart each of the elements it's iterating through. And in this case, that means each element of the dice enum. Now when we add this, comma, ID : / .self, we're telling the ForEach statement that you can consider each element of the enum to be unique. Now this is the case, but we can do something to our enum to explicitly declare that yes, each element is unique, and you can find that uniqueness in a built-in ID property. Once we do that, we don't need the ID : / .self stuff, and even though this isn't super important with enums, I'll show you the technique now because we're going to repeat it in later lessons when we create arrays of our own custom structs and classes, and we want each element in those structs and classes to be uniquely identifiable. So to explicitly declare each element in our enum as being identifiable, let's head up here to that enum, and after the colon, where we also say that this is an int and it's case iterable, we're going to say comma identifiable with a capital I. Now when we do this, we're saying in Swift speak that we conform to the identifiable protocol. Now that's not a very newbie-friendly phrase, but one way to think about protocols is they are programming techniques that establish rules, or a sort of checklist of requirements. Now protocol requirements might include things like, hey, you need to have certain functions with certain names, or you might need to include certain values like variables or constants with specific names. Now, in the case of the identifiable protocol, it only has one requirement or checklist item. It's that anything that conforms to identifiable has a value named ID, which is unique. Now, we don't have a unique ID parameter in our enum yet, so Xcode is going to grump. And if we click on the little red circle of anger, we see dice does not conform to identifiable. That means we're not doing everything we need to do in that checklist of things before we can say it is in fact identifiable. It conforms to the protocol. So Xcode offers a fix in here, add stubs for conformance. Let's click fix to add stubs. And when I do this, I like to shout, okay, Xcode, stub me. And in this case, the stub that's created is simply a variable named ID. So the only requirement for this protocol is for there to be a unique property of this structure that's called ID. That's all lowercase, but each ID element needs to be unique. That's what Xcode means when it says :object identifier, but we need to modify this to actually put the uniqueness inside. Now before I do that, I'm going to make a change here. Most developers move any variables that are inside of enums after all the cases, so that's what I'm going to do now. I'll Control I to fix the indent. So now we need to specify how we're going to determine the uniqueness of each ID value. Well, this is going to be a computed property, and I think we saw computed properties in a previous lesson. So essentially when we're using a computed property, we're saying we're not creating a standard variable, which is like a box that holds data. Those are called stored properties. We're not storing a value here. Instead, when we refer to the value ID, we're going to compute what's inside of it. Nothing is being stored. Now, since the dice enum has raw values that are of type int, see this up here, and each of the ints is unique, we can just say that every time we refer to dice.id, we'll compute the ID variable as being our raw value. So here's how we do that. We replace object identifier with a capital I int, and then add curlies with statements that indicate what ID should return. And the stuff we add here in the closure is almost like returning a value from a function. So in between the curlies, we're going to say return raw value, lower camel case, and that's it. Since each raw value is unique, this is a great way to establish a unique ID property for our enum. Now this works great for enums, and in future lessons you're going to learn ways to create ID properties for other kinds of data structures. Now another thing to point out, this return line here says once we compute that value and all it's going to be is just our raw value, then return that whenever we refer to a dicecases.id property. Now, just like when we write functions, if we have a one-line function, we actually don't need the return keyword. This is like Swift saying, oh, there's only one line in here? Well, you must want me to take whatever's on this and return it. So you can delete the return keyword here. It's not needed, and you'll often see that convention with no return value in one-line computed properties. So now that dice conforms to identifiable, we now know each value has an ID property, and that ID property is going to be unique for each case. Then we can head down here to ForEach, and we don't need to explicitly state that we have a unique ID ID property for each element, we can delete the comma through .self. When we don't explicitly state the ID property in our for each statement, Xcode is going to look to make sure that whatever we're iterating on has an ID property. It conforms to identifiable. That's the case with dice. We just made it identifiable, and we're good. If you ever try to for each on something that's not identifiable, Xcode will grump and say it's not identifiable, and it will require you to add an ID or to make sure that you do something to whatever data structure you're iterating on to make it identifiable. Now, computed properties aren't only for the ID property. We can use computed properties for other things too. You see how each button in here has a unique name for its label? Right now we determine this using the string here with a string interp dice.value with dash cited after it. Well, now that we've learned how to create computed properties inside of an enum, this is a good time for a challenge to make sure you understand how to create one on your own. So add a computed property to your enum, call it description. It should compute a string identical to the one that you use in the button title here, and once you've created the description property, refer to it inside of the button's title instead of the string that I've highlighted here. So you should be able to do this. Feel free to look at what you did when creating the ID computed property if you need an idea how to set things up. So pause, give this a shot, and when you're done, let's compare answers. Now, as part of my solution, I'm going to copy this whole string that I've highlighted. This is how we're currently determining the button title. So let's head back to our enum, and below where we created our ID property, I'll create a property for the button description by saying var. Let's call this description, and this will be computed as a string, so we can say :string and in between curlies, and it's totally okay to put those curlies on the same line if you'd like. I'm going to paste in that string that I just copied that determines the button's title, and now we're getting an error here. It says lowercase dice, but we don't have lowercase dice in here. We're actually inside the dice enum right now, capital D dice. So we can get rid of that lowercase dice dot. That was the name we were using when we were iterating through each of the elements of the enum. It's totally okay to just say raw value in here inside the string interp. And also, even though we're on a single line in here, we could have written this across 3 lines if you want. Feel free to choose whichever option you'd like. You'll see both in practice. I'm going to keep mine on 1 line here just to contrast with the statement that I wrote above for my ID property. You could actually put that on 1 line as well if you'd like. And now that we have a description property that can determine our button title, let's head back down to that button, and between the parentheses where the title string was, let's delete that and write dice.description, and we'll see each button still has the same title, but now we determine the title in the enum. Now, did we have to do that? No, but one possible advantage is with the enum's description in the same place as all of its values, if you were going to localize this app for another language, it's easy to find the description in the enum instead of having to hunt through your code and look for your button label, and it was a good way for us to talk about computed properties. So in this brief lesson, we learned about protocols, which are sort of requirement checklists. We often add protocol names after the colon when we define a data type like a struct or an enum. Specifically, we work with the identifiable protocol, which has the requirement that a data structure has a unique ID property. We learned how to create that ID property using a computed property, and we saw that after we conformed to identifiable, we could get rid of that .self ID parameter that was inside of our for each statement. And we also created another computed property in our enum that we use to determine the button's title. Now, most folks would consider these to be solidly intermediate Swift topics. In the next lesson, we'll learn some new animation techniques that we can apply to make our text view delight the user when it exposes a dice roll. Until then, continue to hack.